Okay, we were solving trigonometric equations last time, and we looked at this as an example question. I think one of the ideas that we got across was that after you go from here to here, using what we know about trig expansions, so there's actually a fair bit of working in there. What you've turned your question into is just a regular old trigonometric equation that has nothing to do with expansions. Okay, so in a sense, what we're doing is we're using expansions to bring out questions like this, which were more complex, to ones that we knew how to solve before. Okay, but there's still lots of little traps to fall into after you get through that point. So let's pick up where we left off. We got into a factorized point, and we looked at the two factors and solved each one for them being equal to 0. Okay, so here's tan x equals 0, and you can solve that with your graph or by remembering the exact values. When you get across to here, because what you've got is a tan squared and not tan x, you just have to be very cautious that you remember when you take the square root of both sides, right? Take tan x. It's not just equal to 1 on root 2. 1 on root 2. Because you could take negative root 2, negative 1 on root 2, you could also square that and it would work for the previous line. So, plus or minus, okay? Now, you may think that's extra work for you to do because there's going to be twice as many solutions, but actually, it simplifies the approach you have to take when you're trying to work out what the right angles are, okay? So, plus or minus means, when you think about your 4 quadrants, these 4 quadrants tell you where each function is positive or negative, right? So when I've got plus or minus, that means I don't have to worry about which quadrant I'm in. I'm actually in the positive quadrant and the negative quadrants. This is for tan, right? So I just take every quadrant and I'm going to get 4 angles, okay? So what you'll need is, at this point, to get your calculator out, because this is not an exact value, and when you punch in tan inverse of just regular old 1 on root 2, okay, what the calculator will tell you, because when you think about what tan, or really what any trigonometric graph looks like, you're getting an infinite number of solutions, right? So I could pick this one, or this one, or this one. I want a few of these, yeah? But the calculator will just tell you the first one that it can find, namely the one closest to the origin. Sometimes it'll go negative as well. So, in this case, the angle it gives you is 35 degrees and some number of minutes. Okay. Now, usually you'd be expected to give it to minutes accuracy, which would be 16 minutes when you do the calculation. But just for the simplicity of this question, and just to illustrate the process rather than focus on the precision of the answer, I'll just leave it as 35 degrees because that's to the closest degree. Now, 35 degrees, that's what you might call your base angle, okay? It's your angle in the first quadrant, 35 degrees, okay? So how do you use that angle to work out what the other 3 angles will be to get your 4 solutions? Well, when you go into the second quadrant, okay, your answer is going to take the form, if I call this base angle theta, okay? In the second quadrant, you're going to be finding 180 degrees minus theta, okay? So that's this angle here, and I've got my minus 35 here, so the actual angle I want is all the way from 0 up to 145. Okay, so there's my second angle. To get my angle in the third quadrant, I don't go 180 minus theta, I go 180 plus. Okay, so there it goes again, there's another 35 degrees. So the actual angle that I want, the whole angle, is going to be 215. Okay, that's what this reflex angle in here is. And when I go into my final quadrant, the fourth one, again I'm going to get another reflex angle. This time, like this, it would be 180 minus theta, it will be 360 minus theta. Okay, so here's our last angle. That's 35 in there. So the actual angle I'm after whips all the way around to here, so it's 325. Alright, so there's my 4 angles that I'm after. 35 degrees, 145, 215, or 325. Okay, so I got 4 solutions from this side of the, or this factor of the equation. I got 3 from over here. So to tie it all up, I need to write all 7 down. Now to be neatest, it'd probably be nice to put all 7 down in ascending order, or at least in some order. But you know, when you're in a hurry, if you're in an exam, that kind of thing, it's fine just to write these 3 down, and then write your other 4. Okay, and there's your solution. Okay. So I think the important things to watch out for in this question, because we had all 4 quadrants. So in some senses, I didn't need to be discerning about which quadrant I was picking all of them. So if you got something different over here, suppose one of your branches, instead of 1 minus 2 tan squared x, right, it was just 1 minus 2, just 1 tan x, okay? When I'm solving this, I've got tan x is equal to a half. So seeing as tan is positive, okay, again, when you come back to your diagram, you just got to remember, you have to disregard some of the quadrants, right? So tan x is positive, so first quadrant and third quadrant will be where my answers are, okay? So watch out for that, and then once you've got all of your answers, you can conclude with all of them in one place, okay?